Alright, so I was explaining something and an idea just came to my mind right now. And it's around why, if I, as an electrical engineering student, explain you what is fitness. That would be great, right? I was looking for my marker, and it's right here. But that's basically what I want to show you in this video. It's fitness explained by an electrical engineering student. And you're gonna say, what the hell is this guy into? Don't worry, I just ate something, but I'm completely fine. But I want to show you my little board right here. I have to study and note all my thoughts about how you can view fitness in another way that most people do. And I wanted to show you my clear way so you can have a better vision if you're working hard, if you're working easy. So one of the most basic components in electrical engineering is the voltage right here. That's the symbol. This is polarity, so the current goes like this. Let's just keep it there. No math at all, right? Just the direction of the electrons flowing. It's that way, okay? Not the other way. My electrical engineering students may say like, it's the other way. It's not. It's like that, okay? So, now that we know what is a voltage, basically, the voltage, it's, imagine a little guy pushing another guy. I don't know, I'm gonna do it like that. Pushing to that way. So that way is this way, right? Then we have another thing called the resistance, which is that symbol right there. And the resistance, let's say that this little guy, which is a voltage, is trying to push him to that side, right, which is a current right there. That's the symbol. And the resistance is another guy or girl pushing him or her to the other side. Not literally, but in terms of, how the resistance works, basically it absorbs energy. So it dissipates a lot of energy right here. Right? So I'm gonna close this circuit and leave it there. No math at all yet. That's the second time I say it. But okay, now I want you to imagine that your resistance is the amount of stress that you can tolerate. Okay? That's the most basic way I can tell you. So, as well as the amount of volume your body can tolerate as well, if you're gonna build muscle or do whatever you want, or if you are running or doing cardio, then how many time your body can adapt to it, right? So, okay, now that we have the circuit here, let's say you're a beginner. You have only lifted for 1 year, so that's 1 volt. Okay. Now your resistance is going to be very low. Your stress tolerance will be very low because you're new at it. It's going to feel hard at the start, right? So it will be 10 ohms right there. Okay. So when we do the math, you already had it there, but let's say the voltage doesn't exist. Okay. Now the current, which is this that I explained, this little guy right here in the middle, is the amount of work that you're putting in, okay? In these terms. Works is another thing on circuit theory, but let's just say here that our work is the current, right? So if we're putting more work in, the more pressure we will have to do it, and the more stress we're gonna have, or the less stress tolerance we will have, right? So in physical terms, when there's a lot of current passing through a resistor of a really small resistance, is gonna burn. So let's say if this is 100 amps, this little guy right here is gonna burn. Okay, so imagine that you're this guy right here and you're doing everything as possible as you can, and this little guy right here, he's gonna fall to the ground, or he's gonna get injured, or you're gonna kill him, right? You don't want that. You don't want to go to prison, right? But that's my point here, which I'm gonna later explain in the video. So now that you know like the amount of work you do, then you need to focus on a balance, and this is where we go to volume, which is the amount of sets times reps times weight, right? Now, it has been very common in the fitness industry, especially when you're gonna work for hypertrophy, that the more sets you do, that equals more muscle you will grow. But that's not true. Sometimes if we just do amount between, let's say, 10 and 20 sets, that's completely fine, and that's completely enough for you, especially if you're a beginner. Okay, so let's say the sets is the amount of current you're putting in. All right, so let's say on the upper end, this is, let's put the same number, let's put 20 amps. Then this resistance is gonna work just fine. Okay, your stress tolerance will be fine, but this little resistance right here is gonna wear faster than we put 10 amperes, which is 10 sets right here. So what would you do? Okay, so now let's say that the wear on this resistor is the amount of stress you put. So the more stress you put to your body, then this resistor is more likely to burn, right? So it's very important that where you're gonna start your fitness, always do the minimum amount first. So for the 10 sets right here, see the 10 sets, that applies for every muscle in your body. So always keep it around that number, even less. Let's say you're working calves. Nobody likes calves except me. It's 6 sets. Your resistor or your stress tolerance will be very, very low. Your resistance will be very low. It's gonna be easy to do those 6 sets. What happens with the same stress tolerance? Now you do 30 sets per week. By the way, this number of sets, it's per week. Then if you do 30 sets of calves, maybe you can tolerate it, but if you have way more experience, right? Or you have a more stress tolerance, right? So that's basically the way that you can observe circuit theory, that I mixed it with fitness, something that just came to my mind, and I just wanted to explain it in my little writing board right here, because it's all connected, it's incredible. So now I wanted to talk about another thing that I mentioned earlier, which is the amount of work, the actual work, right? So in circuit theory, the amount of work or the power administered, it's with a P, and it's calculated the voltage times the current. So you can put more power in with the more experience and the more work you put. But if you put more work, it's because you have the experience. So now let's say you have even more experience, 100 volts, and you can work even more because you know what you're doing. Then you can put here 100 amperes, and your stress tolerance is gonna go all the way up to 100 kilo ohms, which is 100,000 ohms, which is a lot, right? And this is gonna be a really big number if you multiply both of these. is gonna be around 10k watts. So as you can see, I think you already understand how this works, right? You know, the more beginner you are, the easier it is for you to burn out. So this is not only on fitness, this is for everything in what you're doing. You know, if you are studying just like me, or if you're on a new work, for example, your stress tolerance, sorry, right here. So this can count in any endeavor that you're doing, okay? Not only just in fitness. This can be in whatever thing you're doing. So if you're working too hard, your little resistance is gonna burn. But the more you still need to work, but in a way that you don't feel that you're burning out. And throughout the years and throughout the months, you're gonna get more experience. You can input more into that, and this whole circuit, which is you, is gonna perform way better, right? So I think that's the most basic way I can explain you circuit theory mixed with fitness. So if you really enjoyed this video, you can like my video. You can also comment if you want to. If you study electrical engineering like me, which I'm going to graduate in around 2 years. And so I love fitness as well. I'm a personal trainer. So if you want to check my link down below of my school account, as well as my own personal training link of my website, you can check that out so I can train you, and I can also explain you all of these things. If you like this video, again, like it. If you learn something new, you can subscribe to my channel as well. And yeah, I hope you enjoy this video and my little drawings right here, which are not that ugly. I hope so, right? See you in the next video.